So who knows how to play bingo? Right, so we've got corners, prizes, lines, prizes, and then full house out of my beautiful bag. So, right, let's get cracking. Isomorphism. God, an easy one to start off with then. An isomorphism in this context is a pair of functions that will transform objects from one structure to another in a way that no data is lost. So in this example, we're looking at something that can translate a pair to an object and then an object back to a pair, and it's exactly the same thing after you've applied it twice. Tick off isomorphism. We're having fun yet? Right, predicate. Come on. A predicate, generally everyone will know this from using it with a filter. It's a way that you can take a value and return a Boolean value to say whether something matches or doesn't. We use this heavily in our applications. It's something that most people will become familiar with when they're working with JavaScript in a more functional style. A monoid, right. This is where it gets a bit more fun. So a monoid is a semigroup that also provides an empty function. There is semigroup in this list, so I might go back to that one, but it's essentially a way of saying this is how I produce the empty version of myself. In this case, I've produced it with an array, but it could be a maybe, it could be an either, it could be anything of these sort of algebraic data types. Closer to home then, a closure. You say you close over something when you bind a variable in the outer scope and return a function that has access to it. So in this instance here, you pass a prefix in, you return a function that when passed to the string value, it will add the prefix that was previously applied in the top level function. I've forgotten to cross these off. I'll just trust you, sorry, I don't know. Right, semigroup. Good, that came back quickly. So a semigroup is a data type that has a concat function. Typically in JavaScript, you'll see this with the array, but anything that is formally in the sort of Fantasyland spec or more algebraic data type land will also have something similar to a concat that allows you to combine one thing of this type with another thing of that type, and it produces a whole new version of it, so it's not mutating anything. Oh, free call, I guess. This is currying. Great, I didn't go for screen res. The process of converting a function, it takes multiple arguments into a function that can take any number of them, or one of them at a time, and return a function that and will keep that process going until all of the arguments it requires are received, and then it returns a value. So in this instance, this highly contrived example of add, add can be curried to take one, and then you have an add one function that will require one more argument to be passed in, and then it will return a value. In this instance, it'll be 3. Is anyone close to a corner set yet? You've got a line? You're supposed to shout out with a line, aren't you? Bloody hell, man. How's your catching? So there were proper prizes. Purity, this is a big one for functional programmers. The idea is to build your programs as much as possible from pure functions, and that is one that only operates based on its inputs and does not produce side effects. So it doesn't mutate state outside of the function, and it relies wholly on the inputs it's given. So you will always get the same value back given the same inputs. This is a fairly, I guess, low-level thing. It's more done in a JavaScript runtime than anything else, but it's where you can replace a function call with the value that it will return. So in this instance, you see greet will always return hello world, so any place that you call that greet function, you can directly replace it with the string value itself. So you can say that that is referentially transparent. Higher order function, this one's fairly well used. Seriously? A whole line? Lines have gone. No. All right, good corners, right. Corners are mini eggs. Yes. You can have some sweets after, Tom, it's okay. So higher order function, this is probably best known for things like map, filter and reduce, but it can be anything. We use them extensively to produce smaller pieces of functionality for our applications. So you can see in this one here, its filter is our higher order function. It takes a function and a value, and it will return a shortened list, I guess, based on that predicate being run. It's a fairly well-known thing. It's a function that takes as an argument or returns a function as a value. A functor. So this is one that we all probably use quite a lot if we're using JavaScript day to day, mainly through using map on a array type, but it can be on anything like a maybe or an either or something like that, and it's a way of accessing the value stored inside a container object. So in this case, mapping over an array of strings, it's got identity at the top there, so it's just going to return itself, but you could do something like append values, you could do something like turn it to uppercase, but it will always return it inside the container that it was in to start off with, which is really important if we ever get to monad. Applicative functor. So this is a way of applying the contents of a container, which is a function, to the contents of another container of the same type, if that makes any sense. So here you can see you can create a just, bear with me if you've never seen this before, a just of a partially applied function called add, and then you can pass in a value of 5 in another just, and it will return a new just with the full value of 7. So you take the insides of one, pass it to the function that's inside the other one of the same type, and get some results. And at the bottom, there's a more concrete example where you can see that if you create a function called inc and apply it to and put it in an array and apply it to another array containing 1, it will increment that value to make it 2. An endomorphism, jumping around a bit. So an endomorphism, if we go back to a morphism in a bit, that will make it more obvious, but an endomorphism is a morphism where the output type is the same as the input type.
Ian, what's corners?
Corners has gone.
Corners with these.
We're waiting for full house. Everyone is waiting for this to finish. Function composition, something that you will see quite a lot in languages like Haskell or Elm or something like that, but we use it a lot as well with Ramda, the library. It's a really nice way of working to build up an application from smaller concrete parts. So here you can see composes a function that takes function f and a function g, and it will apply the output from calling g with x to the input of f. So it's a way of saying, I'm going to take a function and take the output of that and pass it straight into another one. And you can build up big chains of these things so that you can create a pipeline of processing. And it's really useful if you are interested in building a point-free style of application. Which might be, it's next, excellent. So point-free, it's a way of writing functions without explicitly declaring their inputs. So in this example here, there's two ways of writing an increment all. One of them is declaring that it wants numbers as an input. The other one is just creating new functions from automatically curried functions that will produce exactly the same effect. So the bottom thing here, map add1, is a way of saying, given an array of numbers, I will map over them with the function add1. Yeah, good. Partial application, probably a bit more standard JS, this one. So it's the process of pre-applying values to the inputs of a function. So here, with add, it's really simple. You can use the bind method, function, whatever you want to call it, to say, I want to pre-apply this add with 5, and it gets you the same as currying it, but it's just a bit more explicit and a bit more sort of standard JavaScript-y stuff. Is anyone close to full house?
5 off.
5 off. God, how many have we got left? A pointed functor. A point functor is just a way of creating a functor using of. There we go, simple. Auto currying is a way of taking advantage of currying as a concept. Libraries like Ramda or Lodash-FP use it extensively. If you haven't seen it, there's a really good talk by a guy called Brian Lonsdorf called Hey underscore, you're doing it wrong. If people have used underscore, I definitely recommend you take a look at this, because it's about switching the order of the parameters to a lot of the sort of typical functions that you would get in a library such as that, so that you can partially apply, you can curry them by default, and you can start to build up really comprehensive applications from really small, well-tested parts. A setoid. It's just an algebraic data type that implements equals, and there's some properties around that, like transitivity, that it needs to hold, where if A equals B and B equals C, A is equals to C. I don't know what's gone wrong there. Monad's busting out of its box. So monad, probably one of the least understood, mainly by me, of these things, but essentially it's a way of mapping over something but taking the resultant value out of its container. So it requires these of and chain. Of is less important for this example, but chain's the main one. You can think of it, it's also called flat map or something else, what's the one, bind in Haskell. And it's a way, so if I've got some arrays that get converted from strings here, so you can see there's an array of this is some stuff, and I map over it, I get an array containing two arrays. If it's a monad and I run chain, I get one array with all the values split out. So it's a way of lifting things out of their boxes as a return type. Whew, we got through that one. Arity, really simple. It's the number of arguments a function expects. So you can say something is unary, binary, ternary, etc., or it's variadic if it takes any number of arguments. Foldable. This better known as reduce. It's a way of taking a data type and iterating over the contents of it, or running a function over the contents of it to return a different type. So you can see you can make an accumulator using add to take an array of numbers and turn it into a single value. Idempotent. This one's quite a good one. It's idempotent if the result function can be reapplied to the result of applying it in the first time, and you get exactly the same thing out. So abs, in this case, running it with 10 as the input will always return 10.
Bingo.
Boom. Excellent. Congratulations. Well done, mate. There's like 3 left. Do people want me to continue, or shall I shut up now?
Yeah.
Way. A side effect of this is everyone's going to go away and get drunk. So side effect is where some state outside the scope of your function is mutated based on that function being called. So if you've got some global scope with a foo in it, and then a function runs with some input and it changes it outside, doesn't return anything, that is definitely full of side effects. More typically, you'd see a side effect be manifest in something like an error being thrown or an exception being generated by some code like JSON parse. You wouldn't expect that to be a side effect, but it's an unexpected output that's differing from what you should be getting. A morphism. This, the very first of the 3 that should have been talked about, really. It's basically just a transformation from one structure to another, and in code terms, you could consider that just to be a function. And last but not least, a side cause, one of the lesser known ones, I guess, but this is... Who's got a bingo? It kind of already gone, hasn't it? But what do you reckon? Haribo or buttons? Right, okay, last one. Side cause. So a side cause is where the value that you get from a function isn't just generated from the inputs given to it. It's where there's like a hidden dependency on that function. So it might be pulling in something from state. It might not actually change that thing, but it's always going to, you don't know what you're going to get back because you can't rely on the inputs being the only source of truth for the output. And that is it. Thank you. Sorry.